So what we're going to do now is we're going to do a utility maximization. We're going to maximize our utility. We're going to choose how much of C and G to consume to maximize our utility of C and G, subject to the constraint that we're not going to spend more money than we have. So the money we have is I. Okay. And I'm just going to specify, I'm going to say that my utility function is the square root of C times G. Okay, so this is the same as a previous video in which I did a utility or an expenditure minimization. So I'm using the same utility function. So that means these two are going to relate to each other, and we'll be able to show that duality holds. Okay, so let's set this up. Simple Lagrangian. Okay, now I might rewrite it just to simplify the notation, make it a little bit easier to solve out. I'm going to distribute my lambda. I don't have to do that, but sometimes that's helpful. Okay, so now let's find our first order conditions. So we're going to find our first order conditions. First one, derivative of L with respect to C. Second one, derivative of L with respect to G. Third one, derivative of L with respect to lambda. Okay, so let's start here. Derivative of this term with respect to C, we'll bring that 1/2 down, C to the negative 1/2, G to the 1/2. Okay. Derivative of this term, 0. Derivative of this term, negative lambda PC. Derivative of this term, 0. So this all equals 0. Now I'm just going to rewrite this, simplify it a little bit, because I can simplify this term. So it's G to the 1/2 over 2C to the 1/2. Equals 0. Okay. All right, let's do the same thing, but now for G. G is going to look very similar. Okay. The 0. I'm going to simplify it. Again, it's going to look very similar. Okay, and then this is just our constraint. Zero. Okay, now let's take these, solve them both for lambda, and then we'll be able to simplify. So let's see. Solving 1 for lambda. I'm going to go step by step here. PC equals minus 1/2 2C to the 1/2. Okay, let's cancel out our negatives. Divide both sides by PC. Lambda equals G to the 1/2 over 2C to the 1/2 PC. It's a little bit hard to see here. I wrote that a little bit too small. That's a 1/2. Hopefully, here, I'll write it a little bit bigger. Okay, hopefully there we go. All right, let's do the same. Solving 2 for lambda. Okay, so I just rewrote this, but I took this to the other side. All right, let's cancel out these negative terms. Same thing as multiplying both sides by -1 or dividing both sides by -1, same thing. Okay, let's divide both sides by PG. We'll get lambda equals c to the 1/2 over 2g to the 1/2 times PG. Okay, then we're going to set those two things equal to each other, and it'll simplify considerably. So g to the 1/2 over 2c to the 1/2 PC equals c to the 1/2 over 2g to the 1/2 PG. Okay, let's get rid of our denominators. So we're going to multiply both sides by both denominators. Okay, they cancel out here. That will give us 2g to the 1/2, 2g to the 1/2 PG times g to the 1/2 equals c to the 1/2, 2c to the 1/2 PC. Now we'll notice the 2's can cancel out. We can multiply the g's together and the c's together, so we'll get g PG equals c PC. Let's just solve this for g. Okay, we're going to take this, plug this into our third constraint, our third first order condition. All right, so our third first order condition is this one. Equals 0. We're just going to plug this in. Equals 0. Okay. These will cancel out. So it's I minus PCC minus CPC equals 0. These are the same thing, so it becomes I minus 2 PCC equals 0. Now solve this for C. We'll get 2 PCC equals minus I. Cancel out the I, cancel out the negatives. Divide both sides by 2 PC. We get C. This is going to be our optimal C. I divided by 2 PC. We're going to take that, plug that back into our G. Plug that into our G to get our optimal G. All right. So let's just come back up here, plug that in to get our optimal G. So G star will equal I divided by 2 PC times PC over PG. The PC's cancel out. We'll get I over 2 divided by PG. But by that rule that we keep coming up against, we've got that rule where if I have A divided by B over C, that's the same thing as A over BC. So by that rule, G star is equal to I over 2 PG. So there we go. We've got optimal C and we've got optimal G. All right, so now let's calculate lambda star. Lambda star, we'll do is we'll take our lambda and we'll plug in optimal C and optimal G. All right, so all I did is I took my equation for lambda, and I plugged in C, I plugged in G. I just plugged in the values. So here we go. Now we're going to simplify this. Let's simplify it. So to simplify it, first thing I do is I'm going to distribute the exponent, because I think that makes it easier. And I'm going to bring all these terms up to the top. So it'll be 2I to the 1/2 PG divided by 2 squared PG squared. All right, I'm going to take this, I'm going to flip it, multiply it by the top. So then that'll be I to the 1/2 times 2 to the 1/2 times PG to the 1/2 divided by 2 to the 1/2 PC to the 1/2 times 2I to the 1/2 times PG. So I did is I took this and I flipped it. So that means multiplying this times this and multiplying this times this. Okay, so that's what I get. Do some canceling out. 2 to the 1/2 cancels out, and then I to the 1/2 cancels out. So let's write that down here. PG to the 1/2 divided by 2 PC to the 1/2 times G. Now we're going to simplify this again using our algebra rule. If I have A to the B divided by A to the C, that's equal to A to the B minus C. So this is equal to PG to the 1/2 minus 1 divided by 2 PC 1/2. Okay, this is equal to PG to the minus 1/2 over 2 PC to the 1/2, which is the same thing as 1 over 2 PC to the 1/2 times PG to the 1/2, which is equal to 1 over 2 times the square root of PC PG. So that's my lambda. So now let's write out all of our optimals. Star is I over 2PC. G star is I over 2PG. And lambda star is 1 over 2 square root of PC PG. Now if I want the value function PC PG I is equal to the utility function with optimal C and optimal G plugged in. It's also equal to lambda or L with C, G star, and lambda star. These two things are actually the same. I'll let you discover that in the homework. Okay, so then let's plug that in. Let's find our value function. So we're going to plug in our C star. Okay, let's simplify this. So I, so this will be square root, I times I is I squared. It'll be 2 times 2 is 4. So PC, what did I write here? Oh, this is supposed to be a G, sorry. PG. Okay. Now let's rewrite this using our exponents. Okay, we can distribute this if we want. So this would be, all right, right, 1/2. Okay. Algebra rule, a to the b raised to the c is equal to a to the b times c. So that means this becomes I is 2 times 1/2. So this becomes I. All right, 4 to the 1/2 is square root of 4, which is 2. Now I'm just going to rewrite PC, PG. So there we go. My value function is equal to I divided by 2 square root of PC, PG. Okay. In another video, I'm going to show that duality is true. Thank you.